Let's solve this logarithmic equation. Notice that this problem has two logs. We want to condense it down to where we have one log. So I see that I have a plus sign. A plus sign came from a product. Therefore, I have log base 2 x times x minus 7 equals to 3. Remember, the sum comes from a product, so I took x and multiplied it times x minus 7. So now I've condensed on the left side down to one log. Once you get it down to one log, change it to exponential. That's how we solve a logarithmic equation. So change it to exponential. I get 2 is my base to the exponent of 3 equals to x times x minus 7. Now I need to solve this. 2 cubed. 2 times 2 is 4. 4 times 2 is 8 equals 2. Distribute. X times x is x squared. X times negative 7 is negative 7x. Now we have a quadratic equation because we have a variable raised to the second power. That's a quadratic equation. We want to get everything on one side set equal to 0 and try to factor to solve this quadratic equation. So let's subtract 8 from both sides. I get 0 equals to x squared minus 7x minus 8. I can't subtract 8 from an x term, so I just have to write them all three down in descending order. Now let's factor. So I have x and x. Factors of 8, 1 and 8, 2 and 4. Well, if the back sign's negative, that tells me signs are different. So which pair of numbers, when you subtract, do you get 7? Well, it's 1 and 8. Since I need negative 7, when I FOIL these two binomials, I need to give the sign I want, which is negative, to the larger number, negative 8, positive 1. If you go back and FOIL these, you would get what you started with. Next, by the principle of the zero product, set each one equal to 0. And solve. Let's add 8 to both sides. I get x equals to 8. Subtract 1 from both sides. I get x equals to negative 1. So at this time, I have negative 1 and positive 8 as my answer. But we have to check these. You can never take the log of a negative number. So if I was to plug in 8, I'm taking the log of 8. That's positive. That's good. I'm taking the log of 8 minus 7. 8 minus 7 would be 1. I can take the log of a positive number. You just can't take the log of a negative. So therefore, plugging in 8 back in for x in the original problem, it's still asking me to take the log of a positive, so 8 is a good answer. But if you plug in negative 1 back into the original problem, log base 2 negative 1, it's asking me to take the log of a negative number. You can't do that. Therefore, we will cross out negative 1. So the only answer to this problem would be 8. So once you are finished working your problem, you have to check and make sure that your answers are not requiring you to take the log of a negative, because you cannot do it. Therefore, when we checked negative 1 and plugged it in, it was asking me to take the log of a negative number, and I cannot do that, so I had to cross it out. Let's look at our next example. Okay? Again, we're solving a logarithmic equation. I have two logs. I'm going to condense. That's the first thing I want to do, is to condense here. Okay? Well, I see that I have a minus sign. Therefore, a difference comes from the quotient rule. X plus 2 goes on top, and x minus 1 in the denominator equal to 1. So I condensed. I went from the difference rule down to, or difference told me that I needed to do a quotient. Now let's change to exponential. 4, the base raised to the power of 1, equals to x plus 2 over x minus 1. To solve this problem, think of 4 over 1. Let's get rid of the fractions. We can multiply each term through by a common denominator. My LCD would be x minus 1. So let's multiply both sides by x minus 1 to get rid of the fractions. If I multiply the left side by x minus 1, I get 4x minus 4. If I distribute, 4 times x is 4x, 4 times negative 1 is negative 4, equals 2. When I multiply the right-hand side by x minus 1, the x minus 1's cancel, leaving x plus 2. Solve for x. Subtract x from both sides. I have 3x minus 4 equals to 2. Let's add 4 to both sides. I have 3x equals to 6. And divide both sides by 3. So x equals to 2. That's the only answer that I got. But let's make sure that it does not require me to take, when substituted back into the original problem, that it does not make me take the log of a negative number. Now I'm going to work this one out. Actually, I'm going to check it over here on the side. I'm going to work out the whole thing. Checking it, I have log base 4. I'm going to plug in 2 in for x. That gives me 2 plus 2 minus log base 4 of 2 minus 1. Does that equal to 1? Okay, does that equal to 1? Well, log base 4 of 2 plus 2 is 4. Minus log base 4 of 2 minus 1 is 1 equals to 1. We can evaluate both of these logs. Think of evaluating log base 4, 4. Think about it. Base 4 raised to what exponent is going to give you 4? Does that give you 1? Minus 4 raised to what exponent is going to give you 1? In 4 to the 0, 1. So that's 0 equals to 1. Is 1 minus 1? Is 1 minus 0, does that equal to 1? Yes, so we get it down to the left side does equal the right side. Therefore, the only answer to this problem is 2.